Hey everyone, and welcome back to another episode of Dr. Kyle Explains, your YouTube channel where we go through GCSE science content quickly and easily. Today we're going to be going over the mole and Avogadro's number. So if you like the sound of that, please give the video a thumbs up, subscribe to the channel, tell your friends about it, grab a pen, grab some paper and grab a calculator, and let's go ahead and jump in. Okay, so some key content first of all. So chemical amounts / quantities are measured in moles. The symbol for mole is MOL. The number of atoms or molecules or ions in a mole in a given substance is the same as the Avogadro's constant. 1 mole of any substance has the same number of molecules as any substance, even if the mass is different. So for example, if you had 1 mole of carbon and 1 mole of lithium, they both have exactly the same number of atoms in, even though they will have different masses. So one will be 7 grams, one will be 12 grams, but they'll have the same amount of atoms in. Okay, so the equation for moles. So moles equals mass divided by mR. Now this is an equation for higher tier only pupils. You do need to learn this. You will not be given this in your exam. So what this equation basically tells you is if you had, for example, 12 grams of carbon and you divided it by the mass number of carbon, which is 12, you would have 1 mole. Now what that means is you have exactly 6.02 times 10 to the 23 atoms of carbon. Okay, so this number here is known as Avogadro's number. Now you do need to know this number off by heart. It can come up in tests. So the way I like to explain this is, as chemists, we use the Avogadro's number, and it's very similar to the word dozen. So if you went into a bakery and asked for a dozen sausage rolls, you would obviously get 12 sausage rolls. So a dozen means 12. And so all we have to think of as a chemistry unit essentially is a mole is a unit, and it equals 6.02 times 10 to the 23 when you have 1 of them. And so if you have 2 moles, you have twice that number. If you had 0.5 moles, you would have half that number. Just as in a dozen, if you had half a dozen, you would have 6, or if you had 2 dozen, you would have 24. Okay, a quick recap on molecular mass. So what I'd like you to do is really quickly just see if you can work out the molecular mass of these 2 molecules here. Have a go, pause the video, and I'll quickly go over it, as it's really important that we can actually work these out before we go on to working out moles. So hopefully we got 490 and 331. Now, just as a really quick recap, so we've got 2 golds here, so we've got 197 times 2. Put some brackets around there, plus your sulfur, which is 32, plus 16 times 4. And when you add all of that up together, it should come out at 490. And this one, lead, is 207, plus 14 times 2 for your nitrogen, plus 16 times 6 for your oxygen. And when you add all of that up, that should be coming out as 331. Really well done if you got those right. Okay, so what we're going to have a look at now is we're going to have a workout of the number of moles. So again, pause the video if you want to have a go at this, or if you just want to see how I'm going through it, then please feel free to just follow along. So, got the mass numbers here. Remember, you're always given the mass numbers in your exams, but you can also find them on the periodic table. So, 18 grams of water. So, water has a molecular mass of 18. When we work it out, so we've got 2 hydrogens, 1 oxygen, and so hopefully we can see 18 over 18, because moles equals mass over mR, equals 1 mole. And so in 18 grams of water, you have exactly 6.02 times 10 to the 23 molecules of water. Okay, 20 grams of CO2. So carbon dioxide, you've got 12 plus 16 plus 16, so that's going to come out as 44. So we're going to do 20 over 44 really quickly on our calculators. 20 divided by 44, just got it down here on the side to me, and equals, that comes out as 0.45 moles. So 0.45 of 6.02 times 10 to the 23. 10 grams of H2SO4 then. So we're going to have H2SO4 comes out at 98. So we're going to do 10 divided by 98 equals divided by 98, and that comes out as 0.1 when you round it up. 0.1 mole. And then lastly, we've got 15 grams of potassium carbonate. So potassium carbonate comes out as 138. And so I'm going to do 15 divided by 138 equals, when we do it, so if we just round that to 2 decimal places, 0.11 moles. Okay, and so this is 0.45 of 6.02 times 10 to the 23. This one is 0.1 of that number, and this one is 0.1 again of that number. Okay, so let's rearrange that equation then. So we've got moles equals mass divided by mR. And so if we're going to rearrange that equation, it's going to turn into moles times mR equals your mass. And so here then, here's your molecular weights. So you've got 1 mole of water. And so what we're going to do is we're going to do 1 times our mR, which is 18. And hopefully we can see that's going to come out as 18 grams, which links back nicely to this question just here. Okay, 2.5 moles of CO2, so I'm going to do 2.5 times 44. If I just quickly do that on my calculator down here, times 44 equals 110 grams. 0.5 moles of H2SO4 equals 0.5 times 98. So I've got 49 grams of that. And then 1.3 times 10 to the minus 4 moles of potassium carbonate. 1.3 times 10 to the minus 4. Now, please do not be scared the fact that it's put in a standard form number. It just means a really small number, and they often come out in standard form when working with moles because obviously atoms and molecules are really small. So if I just quickly do that, 1.3 times 10 to the minus 4 times 138 equals, and I get 0.02 grams if you round it up. Really well done if you got those right. Okay, lastly then, work out how many atoms in. So molecular masses again, or atomic masses rather. So I've got 18 grams of water. So what would I do here? Well, I always think, what could I work out? So I've got 18 grams of water. I know 18 over 18 equals 1 mole. And then obviously to work out the number of atoms or the number of molecules, I would just times that by the Avogadro's number, which in this instance would be 6.02 times 10 to the 23, because you're just timesing it by 1. Have a look at this then, 20 grams of CO2, so 20 divided by 44 is going to give me my number of moles, so that comes out as 0.45 that we worked out earlier, and I would just times that by 6.02 times 10 to the 23. So if I go times 6.02 times 10 to the 23 equals, and that tells me that in 0.45 grams of carbon dioxide I have 2.74 times 10 to the 23 atoms or molecules of carbon dioxide. Really well done if you got those right. Okay, so today then we've described what a mole is using Avogadro's constant, we've stated the SI units, and we've calculated the number of moles or masses of substance. Thank you very much for watching. Please do go through my other videos for more GCSE science content. And remember, if you ever need help with the GCSE science, Dr. Kyle explains. Bye-bye.